Okay, now I'll show you how to train unit semantic segmentation models with PyTorch. Let me show you one example. You see the segmentation of the road here. And here you see the input image and output mask. So there will be 4 main steps: set up the environment, dataset preparation, training, and in the end, testing the model inference part. So I will share a link to this article in the comment section. You can find all of the code and other necessary things from here. But now let me start with set up the environment part. So for training models, you need to have GPU supported PyTorch environments. If you don't want to spend time on creating GPU supported PyTorch environment, you can directly go with Kaggle or Google Colab. But let's say you want to create GPU supported environment locally. So first you need to create new Anaconda environment. You see here. And after that you need to install PyTorch with GPU support. Depending on your CUDA version, these values might be changed. They will change for sure. But let's say you got any error during installation, you can follow this article. Installation guide for GPU supported PyTorch environment. You can follow this. So after that, you need to clone unit repository. Let me show you repository as well quickly. Then you need to install helper libraries. I cloned this repository and you see here there are a few more libraries. You need to install these. And here is the repository. There is one installation guide here as well with Docker and without Docker. You can follow these as well. It's up to you. Then in the end, you can check if your environment is GPU supported. I will check mine as well. First, I will activate my environment. I named as unit. Oops, there's some problem. Okay, going to activate units, and this line, it basically will show like CUDA is available and my GPU. So you see here CUDA available true and my GPU, so perfect. So second part is dataset preparation. I randomly choose dataset from RoboFlow, but you can choose any dataset. This pipeline will work with any semantic segmentation dataset. So you see this is a small dataset because I don't have powerful GPU, so I don't want to spend time on training. Let me show you a few examples. You see the label here, road. And let's say you want to use this same dataset that I'm using. You have to click this dataset part, download dataset, but of course you have to create a free account. But let me show you from here. Download datasets, continue. And there's 2 different formats, Coco segmentation and semantic segmentation mask. You have to choose this semantic segmentation masks. Download zip to computer, continue, and it will start downloads. I already did that. Let me show you the formats. Yeah, I copied my dataset folder to here under this data folder. See here, this one. Yeah, these are images and masks. So format is like this. Let me close this. Okay. Yes, there's one more important thing. Like we will use this train file for training, and it expects some formats for training about data. So you need to create new 2 folder, images and masks, and you need to copy all of your images to this folder and your masks to this folder. I did that. You can write simple script for that. Yeah, there is nothing special here. If you ask ChatGPT for this, after 10 seconds, you are ready to go. So images and masks here. Where was I? Here. Yeah, I explained same thing here. Yeah, we will use this train file. Let me show you that. Here, train.py. So, by the way, you can change the folder names as well. You don't have to stick with these. You can customize this code. And you have to log in weights and biases, but if you don't want to do it, you need to add this file, this line to code. You need to disable this. I did that. Yeah, you can do it, or it's up to you. So you see here there are functions, so we will use this file. There are some parameters, let me show you that, like batch size, learning rate, scale, if you want to resize your image, class number, and here we have this line for training the model. First, you need to activate your environment from your terminal. You see here. Then this line will start training. There's like epoch number, class number, scale, and page size. You see here my class number is 2 because I have one class road and other one's background. And if you get more powerful GPUs, you can set the scale to 1, like original image, original size. And you can increase this batch size as well. So when I click this, training will start, but I have to be in this directory, the cloned one. Let me clear this. So training will start. It might take some time depending on your GPU and other your like dataset training configurations. So I already trained my model. I don't want to wait for this right now. But in the end, let me close this. I can close this. In the end, you will have like one model for each epoch under this checkpoints folder. I saved my model to here. Trained models. Let me copy these. Where was that? Yes, here. Delete this. And I'll copy these. Yeah, for each epoch, there is one trained model. You see here. So let me show you the training process here from this image. You see there's nothing special. There are like loss values and validation values. You see here epoch number. So I already did that. And in the end, you will have trained models saved on checkpoints directory, checkpoints folder. And let's say you trained your model after like 5-6 hours. And you want to test your model. There's two different options for that. You can directly use predict.py file, or you can write your own code by calling some functions. I will show you both. Let's test this one. I will activate my environment again. What was that? Conda activate. What was the name? Yes, units. Okay, so you see here we will use this predict file. Let me show you that. Yeah, there are like parameters as well. You can change this. So where was my test images? Under this data, here and here. Yes, perfect. For example, this one. Let me copy the path. I will paste it here, but what is that? Okay, no problem. Yes, this the last viz. This will help to visualize the result. And you see the output will be here as well. Okay. Yeah, you see the output. Let me close this and we can check from here. You see the output mask like this. But I think it's better to create notebook and test the model. Let me create new notebook, like notebook. So here's my environment. You see the one I used during training and testing. Now, first we need to import few libraries. And we need to load the trained model. Yes, you can change the name of the model. You see here the architecture. And we need to process the image. Let me choose some image from here. No, not here, from test sets. Yes, here, for example, this one. So basically we are reading image and we are adding batch dimension here for inference. And we can display the results. Yeah, you see the segmentation. You can see the road here. You can change this alpha value for example. Yeah, you see, it's up to you. And it saves the results here, prediction overlay.png. So I tested with other images as well from like real street images. You see the model result here. And yeah, this one as well. You see. Yeah, as I said before, you can follow this pipeline with any dataset. You don't have to stick with this one. And I think that's it for this video. Thanks for watching. See you soon.